Imagine, if you will, that the zero basal state of the electromagnetic field that we live in is not zero at all, but a series of extreme positive and negative peaks, which only measure as zero to our instruments over time. I'm not talking about the phenomenon of photons, which electrons emit, both visible and invisible, which are we're obviously bathed in those at all times. They come from all our devices, lights, all our devices. These can easily be measured with the appropriate receptors, of course. What I'm talking about are the fields that would result from much faster and more regular quark motions within protons and neutrons. Critically, these field pulses are entirely invisible to us. If we could see them, being so strong, rapid, ubiquitous, and pervasive, they would obscure all the useful properties of all the other electromagnetic phenomenon. It would be like always looking through a blinding storm. Moreover, these fields, being so regular, carry very little useful information about their source. Why must these field peaks exist? If we accept that one, electromagnetic fields are physical changes to space-time which establish moving outward radially at the speed of light around charges, and two, quarks are positive and negative charges which cycle within protons and neutrons at near the speed of light. If we accept those two things, then we must conclude that field intensity pulses will occur each time a quark passes moving in any particular direction. Are such peaks consistent with observations? While electrons receive no net push or pull, they do exist as if in the throes of giant intensity peaks. If one considers the special case of a same sign quark being passed by a field intensity positive to positive or negative to negative, the quark would be trapped, unable to speed up because it's already moving near the speed of light in the same direction. The quark field would add a quantum of energy to the passing pulse. Being trapped there and producing a intensified field, the field would grow slightly. And it would always be the same amount for every quark of the same type. Next, the intensity pulse passes the curving quark, giving it a normal push backward, and due to repulsion from a high intensity of the same sign. This blocked forward by the speed of light and normal backward repulsion, which is given only to a near light speed charge moving in the same direction, is a slight net backward push that is consistent with gravity. This is how classical field theory can explain gravity by incorporating the effects of quarks and the hidden field intensity pulses that they would create. Thank you.